Hello and welcome back to the lab. Today on the bench is part 2 of the TG501 video. Hopefully we can finish this up, get this working today. I do not know how many more problems we have to figure out on this thing, but we'll see what it can go. I have to get the top cover off and then pull out those suspected ICs that are in the switch path and get those tested. So I've got the 2281 warming up in power supply mode. Shouldn't be, don't need much except for 5 volts. Going to use a breadboard. I have a mini breadboard with an Arduino attached, but I'm not going to be using the Arduino. And I'm just going to check some gates and see what we find that are bad. If you haven't seen the previous video, this might not make a lot of sense, but there are issues in the switch path with a lot of the ranges, but it also looks like those are caused by possibly some dead gates. So my gates of interest are U330 for sure. So let's start with U330 and see where we go from there. Okay, I have U330 pulled out of circuit, which is a DM7402, which is a 74 series logic quad 2 input NOR gate. So what we will do is turn on the power supply, give it 5 volts. We're pulling about 16 milliamps. It seems kind of on the high side for a 74 series logic, but let's see what the outputs are doing with no signal hooked up whatsoever. So I only have power and ground. Gate 1. Okay. 2 volts of division will be fine. Nothing there, which is fine. That's lab noise. .500 millivolts of division. The scope goes crazy. It's because of this long ground lead. If I touch the ground lead, it goes nuts. But that gate's okay for now. We'll test it here in a minute. Which means it thinks one of its inputs is high. Actually, if both of my inputs are low, it should give me a high. That may have a bad gate already. All right, pair of pliers. Gonna move this jumper link to the 2 gates to the inputs. And I need to tie. Yep, I need a patch wire. Okay, got a bit of hookup wire. So now that I've tied both gates low, we have a high, and then we have a low. But if I tie them to VCC, we should get a low, because they're high on the inputs and it's inverting. So gate 1 works as expected, but is a little funny on startup. Gate 2 is five and 6. Tie that low. Check the gate. Yep, that worked. See if it'll switch. It stays low, goes high, and so that is true. So gate 2 is working. Gate 3. Oh, I'm off by 1. This is easier to read. There we go. This chip is going to be bad. Yeah, we're feeding 5.12 volts in, but when the gate goes high, yeah, this chip's had it. Don't mind the noise, that's just my noisy lab with the current pickup, but if you look, I'm at 2 volts per division, and I'm only going to 2 volts. This isn't going high enough for the gate, so this chip's had it, and it's a little high on the current draw too, so I think that that TTL chip has seen better days. So there's at least one dead IC that I need to order. Okay, well, I have to wait, but through the magic of the camera, you guys won't. I have a lot of ICs to test in this thing, and they're acting kind of marginal, so I have actually ordered some IC testers that will be here in the lab probably next week or so. So we will continue working on that when some of the shipping comes in, and we'll see where we can go from there. And digging a little deeper and looking at it again, and looking at this unit again. Take a look at this right here. As I rotate it through, watch this cam switch. Let me get a light, because the way the lighting's done in here is I'll put this in shadow. So keep an eye on that cam switch right there as I rotated this around, because the cam is actually in the back. So as I rotate this, you'll see that one cam switch never moves. So that is part of our double time marking. Wow. So let me get this knob off. I've already got the center shaft out. So this has come out the front from back here. So I've already got the middle shaft out. I'll get the knob off and I'll take the cam off, and then we will look at servicing that switch. Okay, got the cam switch out and the switch is repaired. To get the cam switch out, you cannot there's not enough clearance to slide it past the switches without damaging. So what you have to do is you have to get, it's 1/2 inch, so a very tiny 1/2 inch wrench to get back in here behind this board to loosen up the nut, and then the whole thing will lift up and then clear the switches. So the reverse to put it all back together is nut and then lock washer. This goes in like so. And then this screws in the front. So I will get that all connected. It's really hard to do that around the camera, so move the camera out of the way, get that reconnected, and then let's see if our time marks are correct. Okay, so got the board back together. This is the minimum it needs for testing. We're still on the external function generator for the 1 megahertz reference. Reference is actually decently on point according to the frequency counter. So let's zoom into the scope. I'm going to turn this on. Let's see if we have a brain. If we have a brain, all we need is a heart. And there we go. Look at that. All right, so let's see. Actually, that's 5 volts per division, so I'm getting a lot of drive out of that. No, that can't be right. 10x, 1x, of course that's a problem. No way it's giving me 11 volts peak to peak. 1.2, there we go. Because it's supposed to be greater than 1. So that makes a lot more sense. Measure off. All right, so we know we're on 1 microsecond. So I'm going to put the dial back on because I still even have the dial off. I just want to make sure the thing fired up and had a mind. So we'll put the dial back on. We'll run it through the ranges, and then as we run it through the if it gives us any more problems, there'll be more troubleshooting. If not, then it's on to figuring out the tuning capacitor and the 1 megahertz reference. Well, it turns out today the lab decides to give. We have a exact match tuning capacitor. So we'll get that thrown in and see what happens. And after fighting with it for a good chunk of time, it has a brain again. I checked all the ranges, and I get time marks on all the ranges. So it's got a brain. Now all it needs is a heart. And then I think we got this thing repaired. So what I thought ended up being an IC problem ended up being a cam switch problem. I'll move over to the cam switches right now and talk about that. Okay, here's the cam switch. I did find one switch that was sitting down, which I recorded previously. So I took this off, corrected that issue, popped it back up. Found another switch that was very fatigued, so I replaced that. I have some extras running around. So we put an extra leaf spring in there. And then when I put everything back together, I didn't have some of the ranges. It wasn't working correctly. Turns out these plastic supports are not symmetrical in where they hold the cam. So if you ever take one of these apart, take note of where the tall pin is and where the short pin is. On this particular unit, tall pin's down towards the back of the unit, short pin's up towards the top of the board. But they're not symmetric, so when I had this one in upside down, when I had that in upside down, it wasn't making contact with the higher or lower ranges, but the higher switch contacts weren't actually engaging. So definitely take note of those. Let's see, what else? That's about it. I got everything reassembled over here, and we're still having some not intermittent issues. Well, no issues. The main crystal's not run, or the main oscillator's not running. Now, one of the things I did find out back here is
what I saw when the unit ramped up, like right when you flip the power on, we got time marks and they kind of spread out and then died. What that was the 100 megahertz oscillator starting, but it not having a reference. So it would come in, start, you'd see it start, then it would fall out of lock, and it would just nuke the output. So that's what was going on, which was kind of confusing. Everything is set now. I've got time marks. Obviously, my function generator is not synthesized in any stretch of the imagination. It's a free-running oscillator, so it's been wild over temperature in terms of frequency. But it is working. I am getting time marks on all ranges, so I got to put the knob back on, put the variable in there, and then we need to address what we're going to do about that the main reference not running. I've been kicking around the idea of doing just a surface mount board, but I'd like to keep the tunability of the reference. I could just throw a crystal in there, let it run, but I won't have any tunability over time. So as the crystal drifts, eventually it'll drift out of lock and the unit will just die. So for the long term, I want some adjustment. So I will speak with the owner, figure out what's going on. Aside from needing an external 1 megahertz reference, this is running. I mean, one of the options I could do is I could upgrade it to the 5 megahertz reference, make it an option 1 unit. That could be done. There's a lot of things we could do to this. All I got to do is put 1 megahertz on pin 8 on a square wave, and it's off to the races. It works. So the question now is, what's the best solution and how do we get there? Okay, my IC tester came in, so we'll turn this guy on. Let's just make sure we're 74 LS00s. And we're going to put that in there. Nope, bad IC. Okay, so the main timer circuit is bad, confirmed. Even though we confirmed it with our other testing, we've now confirmed it with the IC tester. It is toast. My decade counters came in. These are part number 74 LS990Ns from Texas Instruments. Okay, I have added U50 and I've added the appropriate jumpers that I needed. So U50 is the SN74LS90. We have jumper 6, 4, and J1 for the external 10 megahertz reference. So this is ready to go into a power frame. I had to get my TM503 down off the shelf because I have to give it the 10 megahertz signal on this side of the connector. So I'm going to tap 2 wires off, and that will give me a spot to put in the 10 megahertz for this. So the owner did request the external 10 megahertz reference, so they will also have to do the modification to the power frame, because ultimately what you need to do is you need to take a coax cable from here to the appropriate connectors, run it to a BNC in the back of the power frame. That gives you your 10 megahertz that you can get in and to the TG501. So I'm going to get the documentation out. I'm going to wire this up, figure out exactly which pins on B that I need to hook it up. Then we're going to put some power to it, see what happens. I did forget to mention, when you add the external 10 megahertz reference, you do have to remove U100. This chip has to be completely gone. And on U350, which is over here, you guys should be able to see it in the camera, you have to bend out pin 3 of U350 for the external reference. That's called out in the documentation. Okay, we're on side B. You're looking at the right side of the unit is right here. So we have, I'm going to use the middle connector for this. We have pin B28, 27, 26, 25 is the common, 24 is the signal. And what I'm going to do is I'm going to thread these wires up. I'm going to thread these wires up through here to get them out of the way of the connector. And I'm going to pick up my 10 megahertz off of my Leo Bodnar pulsar, because the square wave, I was very diligent in making the lab sine wave 10 megahertz reference for all my spectrum analyzers and stuff like that. Well, I need TTL 10 megahertz for the TG501. So we'll use the Leo Bodnar and get the drive level into about 4.5 volts, and then we'll get everything hooked up and we'll give it a shot. Okay, I've set up the, turn the lights off so you guys can see the scope better because of the glare. I've set the Leo Bodnar pulsar up to a 4.96 millivolt or 4.96 volt peak to peak TTL signal. It ended up needing 16 milliamps of drive current, so that was done. I honestly don't know if anybody has seen the lab computer on the channel, but right over here we have a lab PC, which is my interface for the bench. Here's the Leo Bodnar software config. So we have a 16 milliamp drive current. One's outputted. We have it at 10 megahertz. So that's all ready to rock and roll. I'm going to move you guys back over to the scope, and I'm going to turn on the TG501, and we shouldn't get anything. Then I'll hook up the output, or I'll hook up the clock to the TG501, and then we should get waveform, because without the external clock it should read out of sync and it should just be dead. It shouldn't be outputting anything. So nothing, when I hit the power, nothing is expected behavior. We'll turn off the cheating measurements. There we go. Oh, I almost forgot. The TG501 needs a 50 ohm through terminator, so we have to have it proper termination. And we are on 0.5 milliseconds, and we'll add clock right now. There we go. All right. We'll give it some more. Well, that looks like, and the timing looks actually really good on that too, at least for the time base of the scope. Well, let's run down the rails. 1. This is awesome. As long as we have time marks on everything, this is perfect. This is exactly what it's supposed to be doing. I will have to use the DSA for the faster time bases, because this Rigel's only a 100 megahertz scope. Now we're getting pretty slow. 0.5. All right, it's working. I'm just gonna check the rest of the rails. I'm not gonna make everybody sit through this. So I'm gonna check all the rest of the settings, but I think we're done. And here's the 1 gigahertz wave going into the 11A72, which is a 1 gigahertz plug-in. We are at 1 gigahertz in frequency, and we are outside of greater than the spec'd output of 200 millivolts. So, because we're at 320 millivolts peak to peak. So the plug-in is functioning perfectly. We have a nice stable 1 gigahertz clock. The DSA hasn't warmed up yet, so I was just looking for rough frequency metrics. I could check that on the frequency counter as well, backed up by another GPS DO, and we could just check the frequencies are right, but everything looks really good. I am very happy with this, so I need to get all the screws put back in, and I need to get everything put back together, but this plug-in's working again. Okay, we are going to need to run this unit through a calibration. That process that I have done has been wildly invasive. The time marks are now self-adjusting because they're on the 10 megahertz reference. However, the variable timing, not quite right. So, gonna have to address that, but as soon as we address that, this unit's done and ready to go. So, take a look at that, and we'll see what we can figure out. That could just be a calibration issue, so we'll see if that ends up being what it is. Well, turns out my readout is messed up on this particular unit. So I did the centering, and watching the frequency counter, I get a decent frequency swing, but I'm not getting the correct readout on the display. My maximums are, I can now get it to go high and low like it should, but 1.4% high, 1.6% low, and I can get it to lock. I can get the oscillator to phase lock right there. However, this should not be reading 1% high because this is exactly 10 kilohertz at 0.1. So it's still telling me it's 0.1, or it's 1% high, 1% fast, but it's phase locked at the correct output. So there's something wrong in my readout circuit, so let me take a look at that. Okay, well, in terms of the variable timing, what ends up happening is I did an analysis of the circuit also with the help of the theory of operation, and come out to U220, 218, 212, 210, and 215 are all summed together for a divide by 20,000 in the 1 megahertz counter. So given that the variable time marks were acting correctly, I think these are okay. Also, the comparator's probably okay as well. And I could check this by checking the output on U108C, and I expect there the output to be okay, just given the behavior of the unit and the way the circuit's supposed to work. The display's wrong. So my my high-low lights are working, but I don't get enough digits on the display, and I'm not counting correctly. I have a sneaking suspicion one of these three ICs are bad. U185, U195, and U200. Those are binary decade counters, and they just happen to be chips that I have on hand. So I'm going to replace those three and just see if we can get the unit to fire up, and then we'll dial it down to which one is not working. Well, changing the decade counters. So one of U220, U212, U215, or U210. I've changed all four of those to new 74LS 7904s, and we have the display moving. However, it's still out to lunch. So what I'm going to do is, I've been told that LS logic is not a good replacement for L logic, that HC logic would actually be a better chip for L logic. So I'm going to order some HC ICs, but I'm also going to replace those sockets in there. LS logic is probably too fast for this unit, so I'm going to order some 74 HCs, and I'm going to replace the sockets just to make sure it's not a socket problem, because this has those bad TI sockets. So I'll get those 4 sockets replaced, and then probably I'll square this away unless this display is still a little wonky. I'm hoping one of my chip testers came in, this guy. I'm hoping my other chip tester can actually test, that's still in shipping, can test these decade counters. I'm going to actually pop these decade counters back in as well and see if it's a socket problem. If it's a socket problem, great, I'll just replace the sockets, no big deal. But making progress because the display changed. Okay, so I've been kind of racking my brain as to what was causing this issue, and on a whim I hooked up my TG501 to the TG501 we're working on, because I wanted to make sure before I really started digging into this circuit if I was actually having a counter problem or if I was having a display driver problem. Well, turns out I am having a display driver problem. So it functions as it's supposed to on mine. Everything's working. It's driving the display correctly. So the board's fine. The display board needs some help. So let's see if it was just a loose connection when I hook all of this stuff back up, or if I have a bad IC in the display driver board. I very well could have a bad IC in the display driver board. This one's been driving me nuts. Okay, so I hooked it back up, tested it, fault's still there on the display board. So I know up until this connector, everything is working. Everything's working as expected, everything's working as it should. Something post-cable, or cable itself, this ribbon cable may be bad, something post this connector is where the circuit's faulted. The only thing that's on the other side of this connector, if we come over here, is the display board itself. So we probably have a bad display IC. Let me see what I can find. I don't know if I'm going to be able to find. But let me get the display board out of there. That one's going to be a trick to remove and see what we can find. I'm going to ohm out these cables too, just to make sure we don't have any nicks, cuts, or breaks. Well, here is the suspected bad display board on my good TG501 used as a guinea pig, since I'm going to be recalibrating it anyway after doing the 10 megahertz conversion to that other unit. I want to do it to this one, but same behavior. So we know this TG501's good, we know this board is now bad, and that other TG501 is good. So we have a dead IC on this board for sure, because if I hold that in to do the LED check, all the LED segments light up. So the LEDs are good. The only other thing on this driver board is the driver ICs. So one of those driver ICs is bad. I will replace both for good measure, because it is a royal pain in the butt to get that board out. To get the display board out of a TG501, you have to take the top board off, take the front two knobs off, and then you have to undo the bottom board and kick it backwards just a little bit, and then you can rotate the board out of the socket, because it sits in there like this. So you have a notch there that goes over the main shaft for the mag switches, but yeah, you rotate this out this way, but you need clearance to clear the LEDs in the front display, so it's got to come back just a little bit. You don't have to take the board completely out, but you do have to disconnect the board and shift it backwards about a ½ an inch. Okay, here's how torn out we have the TG501. I have the board completely out of the shell so it doesn't short out on anything. Everything's disassembled. We were having trouble with this digit here, so I replaced this IC with a good one that has shipped in from Canada. Thank you. So this is the N8T06B that was in there, and this is going to be repaired if we see anything other than a 1 on this digit. So this digit was stuck at a 1. If we see anything else when I turn it on, this unit will be at least in better shape and on its way back together. Oh, there's 9. Okay, so I can get all the digits now. Perfect. Okay, 5 and then past 9. So that is now working exactly the same way the other display board was. So the display is repaired. So now I got to get this back together, and then we'll give it one last test. We may be able to send this on its way back to Australia. Also, since we are dealing with some, I bought a couple of spare ICs since we're dealing with static sensitive devices that don't have the protection diodes in them like modern ICs do. I'm going to store them in some blank rail that I have. This is anti-static rail. I got some ends and I ordered some extras just so when I get ICs like this, this foam is good foam, but it degrades over time. So for IC storage, I use rails. And finally, after a quick calibration, which the calibration on these TGs are pretty fast, it's working. Everything is good. Turn off the lights here real quick. Actually, you still can't see that because of the glare. Sorry about that. We'll just move this over just a touch. So we have time marks. Everything's nice and stable. It's not moving. It's hooked up to the GPSDO. Yeah, it's all working. The display IC was bad. That turned out to be a very rare, very hard to source part. Thankfully, Sphere Research in Canada had a couple in stock, so I was able to pick one of those up. But I'm not sure how many of those there are left out floating in the wild. The IC in question is an N8 T06B. N8 T06B. So, I don't know. That's the bad one. So, I've been messaging the owner of this unit back and forth, and he told me that this was sold to him as mostly working, probably needs a cleaning. The end results for what we found with this unit is it had a dead 1 megahertz reference oscillator. I was requested to upgrade it to a 10 megahertz external reference, which we've done. It had a cracked finger switch. One of the joints on one of the board finger switches had a micro crack in it, and it ended up failing on me, so I had to replace that. Oh, it had a stuck finger switch. That's what was causing the dual time marks. It had a dead display IC, and it needed calibration given how far we had to disassemble it to get into everything. And as with all tech gear of this vintage, it needed switch cleaning and the standard maintenance. Oh, and the voltage rails were way off, so it needed the potentiometer mod added for the voltage rails. So not even close to functioning. But it's back up and running now. It should be healthy for a long time. And I do hope the owner enjoys it and gets the use out of it that he was hoping for. So thanks for stopping by, and I will see everyone in the next video. Bye for now.